Hello everyone, in this chapter we will be looking at chapter 5 of Dive into Python. We'll be learning about modules, classes, and class methods. We'll go through some examples of various types of import statements to import modules, as well as how to use class methods. If you're just doing 1 or 2 lines of code, you can just use the shell, but for longer methods you're better off putting them in a file, or if you need them to persist, for example. We already know what modules are. In simple terms, we can say that modules are Python files with .py extension which implement a set of functions. For example, the Python standard library provides the math module with several math functions implemented in it. This might be some review for you, so hang in there with me. There are generally 2 methods for importing modules. Import module name, and you can see this here, import math. This will import the math module into the local namespace, which is another way of saying your current environment or where you are right now, like this instance of the terminal. Now, to use any function from the math module, for example the square root function, which takes a number and gives back the square root value of that number, we can simply type math.square root and then the number that we want the square root of. Not surprisingly, that will give you 2, because 2 is the square root of 4. Another method to get those functions into your local namespace is from module name import function name. As you see in the first method, we always have to type the module name before its function name. But what if we just want 1 or 2 functions from the module? Then typing the module name again and again would be cumbersome. Actually, it kind of is cumbersome regardless. But Python provides an easy way to do this task. You can import a specific function from a module directly into the local namespace so that you can use that function without its module name. And you can see that here in this case, after we imported square root by name from module, now we can just do square root without having to prepend math. You can also import more than 1 function from module by adding their names with comma separation, such as from math import square root factorial. There is one more method to import functions. The Python language always tries to make your work easy. In the first method, we have to prepend the module name, which is inconvenient, but in the second case, we can import functions directly from the module. But what if you want to import all the functions from a module and use them without adding module name in front of them? One method would be to separate all of them by commas, but that's really annoying. So what is available for you is the star from math import star, and that gives you all of them. Now you can access any math function without prepending the name. Another cool thing you can do is give modules a short name. For example, import math as mt, and now you can call mt dot method name and get your response that you're looking for. And to get even more crazy, you can from module name import function name as function nickname. Crazy times. So changing gears a little bit, we're going on to what is a class. Think of class as a blueprint. It isn't something itself, it simply describes how to make something. You can create lots of objects from that blueprint, technically known as an instance. In other words, we can say class is simply a logical grouping of data and functions, the latter of which are frequently referred to as methods when defined within a class. And we define a function simply by writing def function name and then whatever you want. You can actually see that in the companion examples that I have posted on GitHub in the file 1.py, which is here, 1.py. So the link for that will be in the description as always. Now, you have a class with the method say hi. But how do you use this class? Like, Like, how do you create objects or instances of this class? Now, remember that a class is a template for behavior, and that's an important definition to keep in mind. But anyways, you can create an instance of a class like this. Object name equals class name. And I can't enter this, obviously, because it'll say class name is not defined, because class name isn't in this local namespace. But were it there, this would be how you'd instantiate it. And you can see here some of that going on, that instantiating happening here in 2.py. Let's go on from here to look at what the keyword self is. But before that, look at 3.py. Here we have created another object, another instance of the first class object. We have two objects of first class at the same time. A method like sayHi defines the instructions to say hi for some object. Calling the sayHi and then passing a name puts those instructions to use on the first object instances. We can say, here's your object, self, and wants to call sayHi method on it. When we say second object dot sayHi and pass the name, in that case, self is referring to the instance second object. In simple terms, we can say self is the reference of object which is called on a particular method. Now let's take a look at another very important method called init. Whenever we create an instance of class, the first method, which is called implicitly, is the init method. It looks like a constructor which constructs the instance. It acts like a constructor, but it's not a constructor because it doesn't create the instance. Rather, it just modifies the instance of a class. Init is useful when we want to initialize class objects with some default values. For example, we should have a person class. What are the attributes of a person class? Every person should have a name and an age. You can see that here in 4.py. And that should sort of help you get a sense of how name and age are applied to an instance. So every person should have a name and age. 4.py should help you understand the use of init and also the concept of self. I just got so philosophical, my friends. Anyways, note here that the argument name self is not a keyword, but just a name, and you can name it anything you want, but it's highly discouraged because naming the first argument of self in method is a very strong convention. Here's a tangent for you. You ever wonder about creating instances but not destroying them? Where are they going? Here comes the coolest thing ever, the garbage collector. The garbage collector, or GC in short, is responsible for destroying variables and instances which can no longer be accessed. For example, here you have yay equals this number, and then yay gets redefined to being this string. In this case, as soon as you run line 2, the memory allocated for the instance in line 1 will be deallocated by garbage collection. So memory leak, which is a failure to release discarded memory causing impaired performance or failure, is very rare in Python. Now, changing gears a little bit, we're going to talk about special class methods. Special class methods are ones that can be called on objects with syntax different from the ones we've seen above. And you'll understand it with several examples here. Repr returns the string representation of an instance. Whenever you want to print instance, you will either call repr explicitly or implicitly. And the example here can help you understand that better. CMP is for compare. CMP is convenient for you to use, but it's gone in Python 3, and so you're better off using LT, LE, GT, GE, EQ, or NE. Those are all methods on their own, and they stand for less than or equal, greater than or equal, and not equal, respectively. But if you're in 2.7, which I think at this point most people are, the CMP method is available for you, and you can say, is this bigger or less than or equal? And it will give you responses based on that. I'll go through a couple more really quickly. The len method is for length. Get item and set item, you can see that here in 7.py. These are for getting and setting keys and values in a dictionary. And hopefully, if you spend a minute looking at what's going on here, that'll make the concepts more clear for you. Now, all the attributes we have discussed so far pertain to data attributes. They're limited to a particular instance only. And each instance will have a separate copy of their own data attributes, but what if we want an attribute that is related to the class itself and not constrained to a particular instance? Those are known as class attributes. You can even use class attributes without creating an instance of class, but class attributes are all shared every time or they'll be available every time you create an instance of a class. There's this concept of a class namespace and a local namespace. It means that when an instance wants to access some attribute, it first checks into its local namespace, and if it does not find that attribute, then it checks the class namespace. As you might expect, a.py is here to help you understand it better. Where the class itself is defined, we could call that the class namespace. Private functions are functions that can only be used in the same modules. Follow along in 9.py, if you will. You can't or shouldn't access them outside the module. The same with private class methods. The same is true with private class methods which can't be used or called outside the class. To declare a method or function attribute private, start the name with a double underscore, but don't end with a double underscore. Weakly private methods are named with only one leading underscore. You can use them outside the class, but this is just a way of signaling to other programmers that this is a private attribute and you are not encouraged to use them outside the class. We're getting closer to the end, so check out 10 and 11.py. We're talking about inheritance here. Inheritance provides a way to share functionality between classes. For example, say we have classes like dog, cat, and rabbit. These are all types of pets. And so if we were to make a pets class, what would be common for all the animals? Well, we can say they all have a color. Dogs, cats, and rabbits all have a color. And they all have a name. And so if we were to make a pet class like we are here, we'd have those attributes, and then we would allow cat and dog to both inherit from pet, so that you could make, when you're actually making instances of dog and of cat, you can access these name and color attributes without having to redefine it down here. Here's another example here. In 11.py, it should be pretty straightforward. That's about all there is for Chapter 5. I hope it was helpful. If you have any questions, please feel free to ask them in the comments, and I will do my best to answer them for you. Thanks. See you in the next video.